This video is based on a review article on plasticity, variability, and age in second language acquisition and bilingualism by Professor Bertson from the University of Texas at Austin. Let's watch a video by him talking about the topics we're going to see in this present video.
This is a topic that I've worked on for some time and I've fallen in and out of love with. We're going to look at what goes on in critical period research in terms of the actual scope, try to define and conceptualize what critical periods are, looking at what experiences and what biology go into critical periods, and then we're going to look at how these have particular influence on acquisition of language and on bilingualism. We know that there are impediments to second language acquisition. We're going to look at these briefly. I have a long handout that's very dense, and again, we're going to go through this quickly, but it's on paper, so you don't have to take notes on this. What we will know about simultaneous or early bilingualism is that it's not even late acquisition, but also early bilingualism is going to diverge from monolingual first language acquisition outcomes. And by the way, when I talk about bilinguals, I'm not talking about quote-unquote perfect bilinguals where there's balance and both languages are spoken equally fluidly. Bilinguals for me are people who regularly use two languages, irrespective of proficiencies in those languages. We're going to look about bilingualism over the lifespan. Then we're going to apply the critical period hypothesis to the context of second language acquisition and look at the predictions of the CPH-L2A as well as the evidence for and against it. One of the things in particular we're going to spend some time on is about native-like attainment and whether really it is something that the critical period hypothesis should be interested in as a theoretical perspective.
The present review, Bertson's review, looks at variability and plasticity with respect to their underlying sources and at age as a modulating factor in variability and plasticity. In this context, Bertson considers critical period effects versus bilingualism effects, early and late bilingualism, native-like and non-native-like L2 attainment, cognitive aging, individual differences in learning, and linguistic dominance in bilingualism. Now, let's see a definition of what these reviews, definitions of what this review is about. Okay, this review shows how plasticity and age connect with biological and experiential sources of variability, and also suggests how plasticity, variability, and age conspire to frame fundamental research issues in L2 acquisition and bilingualism. Let's see a definition of plasticity first of all.
Not so long ago, many scientists believed that the brain did not change after childhood, that it was hardwired and fixed by the time we became adults. But recent advances in only the last decade now tell us that this is simply not true. The brain can and does change throughout our lives. It is adaptable, like plastic. Hence, neuroscientists call this neuroplasticity. How does neuroplasticity work? If you think of your brain as a dynamic, connected power grid, there are billions of pathways or roads lighting up every time you think, feel, or do something. Some of these roads are well-traveled. These are our habits, our established ways of thinking, feeling, and doing. Every time we think in a certain way, practice a particular task, or feel a specific emotion, we strengthen this road. It becomes easier for our brains to travel this pathway. Say we think about something differently, learn a new task, or choose a different emotion. We start carving out a new road. If we keep traveling that road, our brains begin to use this pathway more, and this new way of thinking, feeling, or doing becomes second nature. The old pathway gets used less and weakens. This process of rewiring your brain by forming new connections and weakening old ones is neuroplasticity in action. The good news is that we all have the ability to learn and change by rewiring our brains. If you have ever changed a bad habit or thought about something differently, you have carved a new pathway in your brain and experienced neuroplasticity firsthand. With repeated and directed attention towards your desired change, you can rewire your brain.
This review article examines a range of features of second language acquisition and bilingualism from the intersecting perspectives of plasticity, variability, and age. Structure and systems that enable and constrain L2 learning at the individual level is conditioned by factors that may be experiential, biological, intellectual, linguistic, cognitive, educational, and identificational in nature. Both variability and plasticity are modulated by the age when L2 learning begins, age of acquisition, neurological maturation, and these and both main and interactive age of acquisition effects on plasticity have been attributed to neurological maturation, to neurochemical and hormonal fluctuations, to decrements of cognitive function over time, to decreases in regional brain volume, to the degree of first language entrenchment at the initial state of L2 acquisition, and to the relative use and maintenance of the L1 versus the L2. Age of acquisition may also indirectly condition learning variables, such as the extent to which individual is motivated to acquire an L2 to high levels of proficiency, to engage in the L2 culture, and to identify with L2 speakers. A comprehensive synthesis of relevant research is beyond the scope of this article, Birdsong states. The goal is to expose the essential nature of L2 acquisition and bilingualism from the perspectives of age, plasticity, and variability. From these perspectives, we can conceive of linguistic attainment in terms of factors that make L2 learners and bilinguals different from monolinguals. It is intended as a generic concept used in context of relative sensitivity, environmental studies, critical of the learning system. In other studies, critical L2 learning difficulties in adulthood are related with hemispheric functional specialization and declines in plasticity that constrains primary language acquisition. More recent researchers have put forth other neurobiological explanations for plasticity deficits over age. For example, on a use it, then lose it model, after adolescence, the circuitry that is required for language learning is dismantled because in adulthood there remains no selection pressure of humans to keep learning languages and the metabolically greedy neural system that subserve language learning. Declines in nigrostriatal dopamine over age are implicated in decrements of cognitive abilities such as attention, sequencing, and suppression of competing information. These domain general capacities are put Regarding plasticity and children, relative to monolingual infants, among bilingual infants, native speech categories take longer to establish. Sensitiveness to speech sounds are maintained until an older age. There is less input per language with an asymmetric relative frequencies of phones within and across the dual language input. There is enhanced executive control and attentional function afforded by bilingualism. The neural circuitry supporting phonetic discrimination is less mature. The circuitry is equally mature but involves a different distribution of neural connections with greater connectivity in prefrontal areas. The regulation of plasticity takes place within a critical period, a bounded maturational span during which experiential factors interact with biological mechanisms to determine neurocognitive and behavioral outcomes. To get a fuller sense of the neurobiology of plasticity and how it might relate to variability in language learning, it is instructive to connect critical period research in the L1 context with studies in L2 acquisition and bilingualism. The essential neurobiological and experiential characteristics of early language learning are authoritatively laid out by Werker and Hench, who describe the cascading sequence of multiple overlapping periods of plasticity that enable the development of phonetic perception in the native language, starting with discrimination of linguistic sounds in the first few months of infancy through the structuring of words, forms, and phonological categories. The chronologies of the onset, the duration, and the closure of each of the critical periods are not fixed, but are manipulated by biological and experiential factors. For example, the timing of the closure of critical periods depends on molecular breaks such as myelin and histone deacetylases, and onset timing can be delayed by sensory deprivation and maternal depression. Thus, it is understood that variability and plasticity go hand in hand, as variability within and across overlapping periods of plasticity is a basic feature of the model. It is commonly believed that L2 attainment to native-like levels among adults is impossible because they have passed the critical period for successful learning. Two general types of evidence are summoned to support this view. The first is the nature of the function that relates age of acquisition to ultimate attainment. The second is evidence for comprehensive native-like attainment across all aspects of knowledge production and processing of L2. Some researchers have argued that declines in ultimate L2 attainment should level off after the end of maturation. That is, age of acquisition effects on L2 attainment should be observed among early L2 learners, but age of acquisition should no longer be predictive of L2 asymptom among post-adolescent learners. On another view, L2 learning is successful up to a certain age, which may vary depending on what language features are being investigated and learning ability, and consequently, ultimate attainment should decline thereafter. Age of effects are crucial to the question of age-conditioned plasticity in L2 learning, since in order to be consistent with maturational effects, the inflection points on the function would need to match up with known maturational milestones. Regarding non-native like attainment, the underlying logic is that language learning is biologically destined to be successful if beginning during a critical maturational epoch in early childhood, and that the failure of late learning to attain native-like competence is the inevitable result of having passed a critical period of neural plasticity. Proponents of the critical period hypothesis for L2 acquisition posit that across the board, monolingual likeness is impossible. The nature of bilingualism is such that the languages of an active bilingual are activated simultaneously and influence each other reciprocally. Given co-activation and bidirectional effects, neither the first nor the second language of bilinguals can be expected to resemble under scrutiny that of monolinguals in either language. Returning to the question of plasticity, it is important to keep in mind that the L1 is permeable in bilingualism. Thus, consideration of plasticity applied to the L1 as well as the L2. The fact that the L2 influences the L1, not just the other way around, suggests that alleged adult L2 learning deficits should not be ascribed uniquely to a maturational determined loss of plasticity. Attested non-native likeness in both languages of an active bilingual has clear implications for theory, to the extent that an account of L2 acquisition predicts that L2 learners should not attain across-the-board native likeness if they have passed a biologically regulated critical period. The evidence of bilingualism effects supports an account under which neither the L2, irrespective of age of acquisition, nor the L1 are completely monolingual-like. Liu and Cao cite studies of L1 permeability in bilingualism, which reveal different patterns of neural activation in the L1 after versus before acquisition of the L2. Introducing the age of acquisition factor, several reviewed studies converge on the finding that early bilinguals relative to late bilinguals, with both sample populations having the same L1, showed greater activation in the left falciform gyrus than late bilinguals when processing the L1. These results suggest that effects of the L2 on L1 processing in imaging studies may be more pronounced with earlier age of acquisition of the L2, as the L2 interferes more with the L1 to the extent that development of the two languages overlaps temporarily. Okay, regarding native likeness, it is important to emphasize that despite bilingualism effects, there are late L2 learners who resemble native monolinguals with respect to targeted aspects of the L2. In brain-based studies, high-proficient late L2 learners exhibit convergence with native participants in the processing of information structure and across varieties of syntactic and morpholo-syntactic features. Son and Gerken point out that the incidence of native likeness may depend on which native speakers the learners are being compared to. For example, in Jeffrey, reviewing studies involving the processing of complex syntax discerned that natives with high memory spans attend to structural features for correct interpretations in online tasks, whereas natives with low memory spans rely on lexicosemantic information, as do many L2 speakers. In Jeffrey argues that non-structural sentence processing observed in L2 speakers is an option that is also used by native speakers when they have limited processing resources, thus underscoring another type of variability inherent in assessing native likeness. Well, as regards variability in L2 attainment with increasing age of acquisition, there are possible sources. In some studies, as age of acquisition increases, the outcomes of learning of L2 morphosyntax appears to become more variable. It is possible that with increasing age of acquisition, motivation to attain accuracy in lexicogrammatical knowledge in L2 will become more heterogeneous across participants, particularly so as goals for L2 learning become more diverse. Cognitive aging may also figure in the mix of candidate reasons for age-related variability in L2 attainment. As regards differences in L2 learning, it is axiomatic that people vary widely in the effectiveness and efficiency with which they learn an L2. Individuals who attain near native likeness in multiple languages tend to be endowed with high working memory capacity, are highly motivated to learn, and strategically apply metalinguistic knowledge and analysis across their learned languages. In addition to these traits, gifted multilinguals score high on tests of intelligence and foreign language learning aptitude and are created persistent and self-aware. De la Rosa et al. Prefer a view of individual talent in multilingualism that relates language learning-induced plasticity in the left inferior parietal region of the brain to enhancements of domain general attentional processes. Their longitudinal study of children living in the South Tyrol regions of Italy, where German, Italian, Latin, and English are routinely used, showed specific multilingualism-induced gray matter volume increases in the LIPL. The researchers suggest that such structural adaptations result from the necessity to apply general memory and attentional functions to processing of more than one language. genetic approach to individual differences in L2 learning is advanced by Wong et al., who specified that the mediating roles of genetically encoded dopaminergic reception and transmission that underlie the acquisition of procedural aspects of grammar. Procedural learning is associated with concatenation of constituents in syntax and with abstract relations between phonology and morphology, and is localized in the prefrontal cortex and basal ganglia. Given what is known about idiosyncratic variability in TA-related gene function, expression, and biochemistry, it is not surprising that individuals with different genetic profiles may have different learning capabilities, with more variation expected in adult L2 acquisition than in L1 acquisition. A feature of bilingualism that conspicuously connects age, plasticity, and variability is linguistic dominance. Regarding plasticity and age, it is not always the case that language learned in infancy is the dominant language of bilingual. The neural mechanisms involved are sufficiently plastic that the L2 can leapfrog the L1 in terms of proficiency and processing ease. As concerns variability, inter-individual differences in dominance relationships are natural consequences of idiosyncratic experiences with skills in and use of the two languages. No two bilinguals are identical in terms of dominance. Linguistic dominance in bilingualism is understood in terms of dimensions: relative performance in a language skill such as speech rate, picture naming, or grammatical accuracy, and in terms of domains, typically the comparative frequency of use of each language at work, with family members, or at school. Regarding dominance, shift, and age, the direction and degree of dominance in the two languages are dynamic over the lifetime of an individual bilingual. Depending on changing circumstances such as immigration, educational and occupational opportunities, and psychosocial identification, the L2 may replace the L1 as the dominant language. Dominance has been shown to be a predictive factor in studies of bilingualism. The role of dominance in bilingualism relates to the question of executive control. A considerable body of research suggests that enhanced executive control is conferred by bilingualism. Recent work by Onis et al. Looks at dominance as a predictor of statistical learning among adult bilinguals in a miniature grammar paradigm. Thus, degree of bilingual dominance in adulthood is associated with different ability to learn a novel language. Conclusion. In this review, we have seen how variation in L2 acquisition and bilingualism is conditioned by age, which itself conditions plasticity. We also know that age similarly conditions individual factors such as language experience, L1 attrition, and linguistic dominance, which are themselves predictive of variation. Age-related effects, of which neurobiological maturation within a critical period is one possible source, cannot account for all varieties of non-native-like outcomes in L2 acquisition. The degree of L1 activation, L1 entrenchment, L1 attrition, and relative L1 and L2 dominance, all of which are affected by age of acquisition, modulate attainment level across L2 learners. We have also considered possible sources of variability in L2 attainment with increasing age of acquisition. These sources range from experiential, education, length of residence, to representational L1 entrenchment, and to cognitive decline with underlying neurologic causes such as dopamine levels that mediate domain general learning and processing. The role of cognitive decline in age of acquisition-related variability in L2 learning outcomes is of particular interest for future investigation. With respect to individual differences in L2 learning, we have highlighted the roles of neurogenetic makeup, higher-order cognitive factors, language experience, age, conditioned learning styles, and motivation.